All right, this is my pseudocode project. Yeah. First, I just had not initial callings, but basically what we're gonna use throughout like the whole code. The first step is calling the two arrays, your two separate arrays, which I have here as A and B, and I also have integers I, J, K to help with the sorting later throughout the code. Here I have step 2 as inputting the elements and the size of the matrix. So here in my example code, integer n and h both represent the x and y values, or in this case the columns and the rows of the matrix. And as seen here, we scan n for the columns, and then we scan r for the h for the rows. Here for step 3, we see we have to loop the two arrays, and then we don't have to enter. Actually, we do enter the exact elements of the array, not the size. Oops. Here we see for matrix 1, I have the two nasty for loops with I and j both equaling 0, I and j being less than the size of the array, and then incrementing down by a value of 1. With the printf line to print the elements, and scan a scan line to show the new array, the new matrix. Sorry. And for matrix 2, we have this almost identical to matrix 1, with the only change being a change in the scan line to print line B. To print matrix B instead of A. Here for part B is where we start. So if the user chooses B, which is choice B, you will start the section of matrix multiplication. First, we have to input the dimensions for both matrices. Then, if the matrix doesn't match the constraints, which for matrix multiplication, we have to go back and retype in the values. As seen here, the constraint is for the column of the first matrix have to match the rows of the second matrix. Here I have two examples. See here in the first example, rows equals 3 for rows for matrix A equals 3, and number of columns for matrix A also equals 3. For matrix B, rows equals 2, and the number of columns equals 3. Therefore, the constraint fails, and you have to retype the values. As seen here. And for example 2 is an example where it's properly working, where rows matches the number of columns in A and B. So we pass, and then the code prints. Continue to enter the elements of the matrix. Here, inputting the elements of the matrix, I have inputting the elements of the matrix. I have %d row and %d column to show the individual inputs of the array. And finally, the last part is to print out both of the new arrays A and B. And then finally, the last part is to perform the matrix multiplication, which, as we used our nasty for loops earlier. And then we set an array equal to 0. And then again, we see our nasty for loops. Then we introduce integer k to sort the new array out. Here, as you see, multiple ij, which is the multiplication of matrix A and B, is equal to the matrix of aik times the matrix bik. And then finally, we print the new array out of multiplication, which would be the multiple of ij, as seen here, %d print array. For part D, once we have our two matrices as we discussed in the beginning, we enter the elements into the matrix. First the columns, then the rows. Next, we enter the value of the elements as seen here. We've using the same process as the as the previous part, where we list all of the values from 0 to the size of whatever size of the array for both A and B. And finally, is to find the determinant of the input. You use systems of equations to set the values of D1, D2, and D3 equal to variables such as dx, dy, dz. I haven't completely figured out how I'm going to write this piece of code, but it'll probably be a header file with a void array. I will set the array and take the equations to solve for dy, dz, dx, and have them as functions, so that when I return my when I input my header file into my script, the function will return the determinants of d, dx, dy, dz. And from those values, I can then solve for x, y, and z.